In the 1990s, your car answered to you. 3 computers under the hood, not 100 watching your every move. You felt every corner, managed every mistake. Today, driver skill is optional, and your car's fate is sealed by software, not steel or sweat. So why did automakers abandon machines built to outlast their owners? And just how much did we lose in the shift? The answer begins with a single key turn. Turn the key in a 1990s car, and the process feels mechanical, direct, almost physical. Under the hood, just 3 or 4 computers handle the essentials: spark timing, fuel delivery, and perhaps anti-lock brakes if you were lucky. Compare that to a modern car where well over 100 microcontrollers monitor every move, from adjusting your seat to streaming your favorite playlist. In the 1990s, the connection between driver and machine was defined by hardware, not software. Throttle cables ran from pedal to engine, every millimeter of movement translating instantly to a surge under your right foot. Steering racks, powered by hydraulic pumps, fed the texture of the road straight through the wheel, no algorithms smoothing out the feel, and no artificial resistance hiding the road. Brakes relied on vacuum and hydraulics to give a solid, progressive pedal. You could sense the grip fading as the pads wore down. This was mechanical honesty. Ask any mechanic who has worked on both eras. They will tell you a 1995 Honda Civic or a Toyota Corolla could be diagnosed with a test light and a basic scan tool. Most problems started with a sound, a smell, or a change in pedal feel, not a dashboard warning or a cryptic code. One veteran technician puts it simply, "Back then you fixed the car, now you fix the computer that runs the car." That comparison is practical. The simplicity was not just nostalgic, it was practical. Every system had a physical pathway. Every response was immediate. There was no buffer, no delay, and no hidden logic. The car's intentions were transparent, and so were yours. That is why driving a 1990s car feels alive in your hands, not filtered through a circuit board. The 1990s delivered a lineup of sports cars that demanded as much from the driver as they gave in return. The Honda NSX, shaped by Ayrton Senna's relentless feedback at Suzuka, set a new benchmark for handling through pure mechanical tuning, with no power steering assist and no electronic safety nets. The Toyota Supra, especially the twin-turbo Mark IV, offered 320 horsepower through a mechanical throttle cable and a robust 2JZ engine that became legendary for its durability. The Mazda MX-5 revived the spirit of the classic roadster, feather-light and perfectly balanced, with steering and brakes that told you everything about the road surface. Nissan's Skyline GT-R, the R32 and R33 generations, delivered 276 horsepower with twin turbos and mechanical controls that made every shaft and throttle input a test of precision. Across the Atlantic, the BMW E36 M3 embodied the same spirit, a 3.2-liter straight-six, manual steering feel, and a chassis that rewarded bravery but punished mistakes. None of these cars featured traction control, stability programs, or selectable drive modes. Skill was the only assist. As one track driver says, "You get it wrong in a Supra, you know instantly. There is no computer to save you. But when you get it right, the car feels alive." Every input, steering, throttle, and brake, was a direct conversation between the driver and the machine. These cars did not flatter sloppy technique. They demanded respect, and they taught lessons in physics at every corner. That is why so many of these icons, from the NSX to the Supra, are still celebrated today, not just for their speed, but for the honesty of their engineering. Stories of car longevity from the 1990s are not just legend. They are logged in service books and etched on odometers. A 1995 Honda Accord, still commuting daily with 400,000 miles, is not rare in owner forms. It is a documented reality. The same goes for the Honda Civic, with examples easily passing 300,000 miles on original engines and transmissions. Toyota Corolla owners echo the experience, reporting 250,000 mile marks as routine, not exceptional. These are not museum pieces. They are family cars, grocery getters, handed down across generations. Owners point to maintenance logs, regular oil changes, timing belts swapped at intervals, and the cars just keep going. Maintenance is the through line. Underneath the surface, the secret is over-engineering, thicker steel, redundant cooling, and engine internals built to outlast the rest of the car. Mechanics note the tight tolerances and robust parts, bearings, seals, and gaskets designed for decades, not just warranty periods. Durability was not a happy accident. It was a promise, built into every component and proven in real-world mileage. A 1995 Honda Accord needs a new serpentine belt. The job does not require a dealer visit or a specialized tool, just a socket set and about an hour in the driveway. The total bill, even at a local shop, rarely tops $200. That level of affordability was no accident. Engineers at Honda and Toyota mapped out parts support for at least 15 years, designing components to be modular and easy to swap. A former Honda engineer recalls that they wanted owners to keep these cars as long as possible. Every major component could be replaced without tearing the whole engine apart. Suppliers stocked shelves with common parts, and independent shops thrived because repair manuals were comprehensive and the cars themselves were built to be serviced, not just assembled. For families on a budget, this meant a reliable car did not become a financial burden when something wore out. The logic was simple. If repairs stayed under $500, owners kept their cars and their loyalty. Open the door of a 1990s luxury sedan, and the first thing you notice is the weight of it. Solid and reassuring, lined with real materials that were chosen to last decades, not just a warranty period. The Lexus LS400 and Mercedes S-Class did not cut corners. Genuine leather seats, real wood trim polished by hand, and dashboard plastics thick enough to withstand years of sunlight and use. Every button and switch offers a satisfying click, a reminder that tactile feedback mattered. Climate control is a pair of dials, not a submenu. The cassette deck, a centerpiece, sits ready for your favorite tape, while CD changers hide under the seat or in the trunk, built for convenience before algorithms chose your playlist. Even the steering wheel tells you what car you are in, stitched leather and unique horn shapes, the kind of detail that ages gracefully. A materials scientist explains it simply. Real leather and wood cost more, but they age with dignity, developing character over time instead of peeling or cracking. These choices were not just about appearance. They were about making every interaction feel deliberate, every surface built for human hands, and every control designed to last a lifetime. Automakers in the 1990s built their reputations on cars that lasted. But as the new millennium approached, the math changed. New vehicle sales delivered slim profits, often just 6 to 8% per car, while the real money flowed in aftersales. Parts and service, with margins of 20 to 40%, became a gold mine for manufacturers and dealerships. Suddenly, a car that ran trouble-free for decades was less attractive to the bottom line than one that cycled out every 6 to 8 years. The industry began to optimize vehicles for the warranty period, not for lifelong ownership. Design decisions shifted. More integrated electronics, harder to repair components, proprietary systems that funneled repairs back to the dealer. This was not about making cars unreliable overnight. It was about nudging owners toward trade-ins when repair costs crept above a certain threshold. The result was a subtle but powerful pivot from building machines that last to building products that keep the profit wheel turning. Federal regulations passed in the wake of the 1970s oil crises divided vehicles into two categories: passenger cars and light trucks. The wording was meant to protect work vehicles, pickups, vans, and off-roaders from strict fuel economy rules. Regulations shaped everything that followed, but the law never anticipated that SUVs and crossovers would become family cars. By the late 1990s, manufacturers realized that reclassifying wagons and tall sedans as light trucks let them bypass tougher standards. A policy analyst explains that under the original corporate average fuel economy rules, anything with a cargo area or higher ground clearance could qualify. The result was a loophole that changed the shape of the American car market. In 1990, light trucks made up just over 20% of new sales. By 2023, that number had climbed to nearly 80%. The SUV boom was not just about consumer taste. It was a rational response to regulation. The incentives did not stop at fuel economy. As onboard computers multiplied, vehicles became rolling data centers. Modern cars transmit driving habits, location, and service needs back to manufacturers. That data, now worth billions, is sold to insurers and marketers. The business model shifted. Profit comes not just from selling vehicles, but from harvesting information. The old 1990s philosophy, build it to last, gave way to a new logic. Designed for compliance, maximize data, and keep the upgrade cycle spinning. What started as a technical classification in a law ended up reshaping consumer choices, dealership inventories, and manufacturer priorities. Regulation, profit, and data combine to rewrite the rules of the road. As cars become rolling computers, the proof remains in driveways. 1990s machines are still running strong decades after assembly. Longevity wasn't nostalgia, it was engineering. Now, as planned obsolescence becomes the norm, the question isn't what we lost, but whether we'll ever demand machines built to last again. Share your thoughts below.